Welcome to the Realistic Industrial Environment course for Blender, made possible by, or at least made practical by, Eevee. You may recognize this environment from the backhoe assembly animation. What you may not know is the backhoe is rendered with cycles and the environment rendered with Eevee. I first tried to render the environment with cycles as well, but I needed it to finish before my kids graduated college, and Eevee came to the rescue. This course walks you through the entire workflow, including modeling, which is very simple, all based on primitive shapes and no subsurface smoothing. Then we move into procedural texturing and material creation, which does most of the heavy lifting visually. While it does get a little more complicated in the shader editor, it's really only a handful of procedural concepts repeated and adjusted in various ways. We'll also look at indirect lighting with Eevee, how to add volumetric fog for cinematic drama, and finish with my go-to post-processing techniques for photorealism. It's about 5 hours of blissful blendering, so if you're into that, let's get started. Our first order of business is creating the primary structure for our underground bunker / parking garage industrial place, which means walls, floor, ceiling, and columns. And all of this modeling is extremely simple. Anybody can do it. The only things we want to be mindful about is keeping our geometry as simple as possible without appearing low poly, as well as maintaining very specific dimensions so that the math works out with an array modifier. But you'll see what I'm talking about. Let's get to work. We're actually going to use the default cube and not delete it. Pretty crazy, I know. With that selected, I'm going to hit the N key and go to our item and look at the dimensions. Now, for the X and Y, I want to make this 72 meters wide and deep, and then 7 meters tall, which makes for a pretty large space if you think of this as a room. And the reason I wanted it so big was so that when you saw the backhoe render, the background didn't seem to stop. It seemed more to just kind of go on ambiguously. But for the sake of this modeling exercise, it's going to be best if you just follow these values precisely, because the math does need to work out once we start adding array modifiers. I don't usually teach like this. I almost never emphasize the specific values, but in this case, it's much easier if you do plug those in and you'll have exactly what I'm going to have. So this serves as the overall dimensions of the room. Let's rename the object walls, and I like to use all caps for very important objects and collections, just a personal preference. Now, I do want this to sit a little bit higher. Anytime I'm working on an environment or a set for an animation production, I like to use the ground plane as the ground, if at all possible. So I'm going to move this in edit mode, all of our components, just to barely sit below the ground plane. And I'll explain why I like it to be a little bit below once I create the next object, which is the floor tiles. However, remember, we changed the dimensions by plugging in values, and that adjusted our scale. So I want to be very mindful of always applying the scale. Control A, apply scale. Now you see the dimensions of the room stay exactly the same, but the scale is all set to 1, which is like an applied default state. And so we can move on from here to add the next object, which will be Shift A mesh plane. I'm going to rename this to be ground tile .000. I will explain the .000 once we get there, but you can just think of this as the original floor tile. Yeah, I called it ground tile, but I think floor is more correct in this case. All right, so by default, all the objects come in at 2 meters by 2 meters, but we want to make this 8 meters by 8 meters. Okay, so we adjust that and then hit Control A and apply the scale. So it's all set to 1. Then I just need to tab into edit mode, and we're going to extrude just below the floor of our room object. Let's see, I actually extruded at an angle, so let's try that again and go straight down in Z. Okay, like that. Okay, here we've got our floor tile. We can delete the very bottom polygon, so X delete faces. And then in edge mode, I can select everything, and I just want to knock off these razor sharp edges of our cube with Control B, the bevel tool. All right, so Control B, something like that should do fine. However, I said that I want to keep this as low poly as possible without actually looking low poly. I don't want to see any sharp jagged edges. And so as I bevel, I want to increase the segments significantly to like let's say probably 4 is going to be fine. The smaller the bevel width, the less segments you need. And so, yeah, I think 4 should be fine to just knock off those edges, and it's rounded enough that from, the typical angle, a camera angle that we'll use, you'll never notice this. Now, I might have made the bevel width a little bit too wide, actually, given the scale of the floor tile. So let me just take that down a little bit. There we go. That should be fine. Now, it's very unlikely that our camera will look at this edge close enough to see the facets. So I could probably leave it like this, but just to be safe, I'm going to right click and shade smooth, which makes it look perfectly smooth. However, whenever you have a very broad polygon like this, and you add shade smooth, you get this overzealous gradient, right? It's too much smooth for how sharp the object is. And so to solve this, what I'm gonna do is tab into edit mode and select all the broad faces. Okay, and then right click and shade flat. Okay, so if I undo that, you can see how the gradient disappears. Now we have actual flat shading. But in the bevel, it's smoothed. Okay, so this is kind of a finalized floor tile that will react to light in a predictable way. If we left it with that broad shaded gradient, it would look a little strange. Certainly strange enough to detract from the photorealism that we're going for. All right, so that floor tile is done. Now we want to place it and duplicate it with an array modifier. So I want to place it right here in the corner. Now I could enable snapping and then try and align it while not, let's see, I'm losing my orientation. But once you have all these vertices in play, the snapping can accidentally snap to one of those verts instead of the corner. In fact, we don't even have a corner vert anymore. It's been rounded over. So we can actually do it much more simply by plugging in values and using some very simple math. So we want this to go over in X half of the dimension of our overall room. Remember, that's 72 meters. So we want to cut that in half in X, which is going to be -36. However, that's the origin. That puts the origin of our object right along the wall. So we need to subtract, or since we're in the negative direction, we need to add half of the dimension of our floor tile, which is 8 meters wide. So we want to add 4 meters, which takes us to -32. And that puts us right here along the wall. And then copy that -32 to the y-axis as well. Now with just some simple math, we are exactly in the corner of our floor. We can go to the modifier panel and add an array modifier. And just crank up the count thanks to the default settings, which puts each floor tile exactly one dimension over in a specific axis in X by default. So we can just crank up the count until we reach the other wall, which is going to be 9. Perfect. Now we just need a duplicate of this array. With the down arrow, click the duplicate option and change the axis. Not in X, we'll make that 0, but in Y, we'll make that 1. Okay, now we've got floor tiles stretching precisely over the space in our room. Now we're ready to move on to the ceiling tiles, which I will hit Shift A and add a mesh cube. And we will use the default 2 meters by 2 meters as the dimension of this object. Let's go to our 1 front orthographic perspective. I'm going to move this, let's see, in object mode, we'll move it up. I'm going to tab into edit mode and scale in Z. And I think that should be good enough. Now this object is going to have a little bit more detail. I'm going to select the face that's facing the room or facing the floor. And I'm going to hit the I hotkey. Well, actually, let me make sure that my scale, before I do an inset operation, let's make sure that the scale is set to 1. The reason I want to do that is all your operations like bevel and inset are affected by the scale. And if the scale is not set to 1, then it's going to be skewed in whatever direction the scale is set. So setting them all to 1 produces standard behavior. I get that question a lot on our site where the tools don't act as they would expect. And the answer is always to check the scales, make sure they are applied at 1. All right, so with this face selected, let's hit the I inset key. And let's just use a value of about 0.1. Okay, you can see the thickness up here in the upper left corner of the viewport is at 0.09. I'll just hit 0.1 and hit enter. Okay, and then Shift R to repeat that operation. All right, so I've got 2 insets, and that last inset I'm going to move up to create an intrusion or an extrusion into the model. I don't really know what the right word is. Intrusion? Extrusion? Either way, we've got a chunk taken out of the volume, and the amount, I think, of like 0.3 meters is going to be good. Don't need to be terribly specific with that. But this is going to create an interesting grid pattern for the ceiling. So with that face extruded inward, let's hit Control B, and I'm going to create a broad bevel to soften that inside corner significantly. All right, so since it's broad, we need more segments to successfully create the illusion of smoothness. I think about 6 should be fine. I don't want to go too high. Remember, we're going to be duplicating this a lot with an array modifier, so we don't want too many polygons, or else the scene will get very sluggish. So 6 looks like a good number. Let's hit Enter, and then the last thing to do is select our corner edges. I'm holding Alt and clicking so it grabs all of the edges in each corner, and then Alt clicking around these 2 edges, and that should be it. Okay. Same thing, Control B, just to knock off those razor sharp corners. Something like that. 6 is probably too much since it's a smaller bevel width. Let's go to 4. Yeah, I think that's going to work out pretty nicely. And right click to shade smooth in object mode. You see that overzealous gradient comes into effect. That's because we have a very sharp edge on top, but we don't actually need this face. So let's just get rid of that face, and then the gradient goes away. So we've got proper flatness on the object. So that should work out fine for a ceiling tile. Let's make sure it's actually in the ceiling. We'll, in object mode, move it up and just slightly intersect. Maybe a little more than slightly, like that. And now to position it in that corner again, I'm going to the top view orthographic with the 7 key on the number pad. So the same situation, we want to go negative half of the dimension of our room, which is negative 36, and then plus half of the dimension of our object. It's a 2 meter object. We want to go 1, which takes us to negative 35 in X and in Y. Control C, Control V. Now we're in the exact corner of the room. Same situation, add an array modifier. We can crank up the count. It should be, let's see, it should be 36, right? 72 divided by 2 meters. Yes, it's 36. And duplicate this and change the direction to Y, or to 1 in Y. All right, now we've got floor tiles. Oh, I should say also, I'm not using any reference, and that's not usually my style. I always recommend using reference, but we all know that I'm building a very specific model from the backhoe animation, so I know how to build that. I don't need to look at images. However, when I built the original, of course I looked at images. And so if you want to build a unique parking garage or industrial structure, my favorite place to go for reference is unsplash.com, because it's very high quality stock photography that's freely usable. It's Creative Commons public domain images. So if we type in parking garage, this is what I sourced when I built the original. So the basics are pretty much the same. There's not a ton of variety in parking garages, though there is enough to be interesting. But I kind of favored more this style where there's this grid-like pattern in the ceiling. A lot of parking garages have smooth ceilings like this. I would say the majority have a smooth concrete ceiling. Like where I'm from, most of them look like this, right? So much more simplified. But I think there was one that looked a lot like what I'm going for. Let me see if I can find that. Yeah, this one right here. So this is more what I'm going for. It's just a little more interesting to me, but I highly encourage that you look at reference. Always look at reference whenever you're building something. And also, you know, take the challenge of creating a unique garage, not just the same one I'm creating. Anyway, I wanted to address why there's no reference being used here, because it's really just all in my head. So we only have one piece of the primary structure left. Let's rename this to ceiling tile.000 before I forget. And we will add one more mesh cube and leave it at the 2 meter dimension, and we'll call it column.000. And this cube will start, let's tab into edit mode. We'll leave the origin of the object at the world's origin on the ground plane. And let's see, we will move this up so that it just barely touches the ceiling tiles. Now I'm not going to be overly precise with this. I'm not going to snap it. You could if you wanted to, but it's just not really that important. And if I'm honest, I think it's a little bit funny. I'm sort of trolling the people that do want it to be perfect, especially when I've been precise with everything else. But I'm just eyeballing this last piece. I think is a little bit funny to me. You can snap it if you want. I'm just being lazy and ballparking it. All right. This is going to be the start of our column with a square portion on top. And then from here, we will transition to a cylindrical column main structure. So Shift A, in edit mode, let's add a cylinder. And I'm going to change the vertex count to 64. All right, this is kind of the balance where having a higher value is going to look smooth. We're not going to see the faceting, but it's also not too high as if we were to use subdivision surface to smooth this all out. So 64 is going to be a good balance. And then let's align it to the floor. Again, all this is happening in edit mode. And I'm just going to get close. I'm not going to bother with snapping. And then the top row of verts, we will grab that. And I actually will make this precise. And well, first I want to scale it a little bit. So let's hit S and Shift Z. All right, so we're scaling. I need to select the whole cylinder, Control L to select linked. And then S, Shift Z, so we scale in every axis except Z, basically just making it a thinner column. And I want to make it just ever so slightly thinner than the square on top, okay? Now let's select that top ring again, that top edge loop. Shift S, select one of these verts. And instead of snapping, we'll do poor man's snapping by using the active element. That's why I selected this one. If it's white, that's the active one. And if we S, Z, and 0, then we're scaling vertically towards that selected element. All right, we are snapped precisely. And the next step is I want to actually sew this cylinder into the cube. I don't want to leave them as separate mesh islands. I want them to be one, and you will see why once we get to the part where we separate all of our arrayed objects. Spoiler alert for a future lesson. All right, so I'm going to erase. Have I ever called that erasing? I'm going to delete those faces. And now to sew them together, it's a little strange because you would think if I Alt-click here and then Alt-click here and hit F, that would work. But you can see it just fills them in separately. We've got two separate faces in this case, just like we started with. So what we need to do to kind of hack the system is connect one edge from each corner and then fill. In edge mode, I'm going to hold Control and select shortest path. All right, so we have this selection. All right, you can see that. And then fill that as one face. All right, once we do that, then we can Alt-click and select this whole border edge and fill that whole thing. It's kind of weird that you need this, but it's just, I think, to define the n-gons a little bit. Without this definition, the n-gons don't know how to fill. We can't even remove these edges. Control X doesn't remove them, so they're required. But now, Control L, they are all connected. The only other thing to do is knock off the edges like we've been doing. So let's select the top face. Control plus to grow the selection. And then to edge mode, I'm going to Alt-click right there. Okay. Oh, and the bottom as well. Shift Alt-click to select that whole edge ring, edge loop. And Control B to knock off these edges, round them over just a little bit like this. Perfect. All right. Right click in object mode, shade smooth. And then do we have any of those awkward gradients? Yes, we do. Or do we not? Let's see. Just to be safe, I'm going to select the broad faces of this cube portion. Maybe this as well. Broad faces that I know I want to be flat, and right click shade flat. You can see a little bit of the gradient got taken care of. So now I can, rest assured that the surfaces that are meant to look flat are indeed perfectly flat. Okay, so we've got our column structure created. Now we want to position, and since it's using the 2 meter dimension, just like our ceiling tiles, we can use that same location of -35 in X and Y. All right, that'll put it directly in the corner. Where are we at? Right there. Perfect. Okay, so the reason I use the 2-meter dimensions is that it directly aligns with the ceiling tile, and that just looks more structurally sound to me rather than if it was off like this or scaled up a little bit. If we scale in, you know, that would look funky. It would look like built poorly, I guess. So the fact that those are aligned is what I want. And next, I'm going to do the usual thing of adding an array modifier, but this one's going to be a little bit different. We're going to use a 6 count and change the factor to 7. I thought I typed 6 here. Okay, so what this gives us is a decent amount of space between each column and a column exactly in the corner, and each column directly aligns with a ceiling tile. That is the goal that I want for the space between columns. But I can't really explain to you the math why this works out. This has been the hardest part of rehearsing this video, is trying to figure out an easy formula. And I just don't know why 6 count, why the 7 is the factor. I mean, obviously you want 7 spaces in between each. But anyway, I got to these numbers by trial and error, not a mathematical formula. I know some of you are watching this thinking this is the simplest math in the world. I've lost all credibility. But the more important thing is the why. This is how I want the structure to look, and this math works out. So we can duplicate the array and just change the direction. Whoops, I hit apply, not duplicate. And change the direction to be 7 in Y. There we go. Now we've got our room populated with columns. They're all perfectly aligned with ceiling tiles. Overall, they all fit within the dimensions of the broader room. And all this math did take, you know, some trial and error to figure out. If you're building your own, you don't necessarily have to be this precise. You can use different values, but it is helpful when they end up in alignment. So that is going to be it for the main structure. Obviously, this looks very simplified, very repetitive. And the next step is going to be adding accessory models that break up the monotony and make it feel much more believable, much more real. So that's what we're going to be doing next.